So, welcome to our today's live stream at Green Delta. So I would first introduce myself. I'm Pia Lemberger, working as a sustainability consultant at Green Delta, and I'm here with our intern Thais. She has been working here at Green Delta for the last 3 months, right?
3 months.
Yeah, exactly. And she has been doing some really good work on the case study in openLCA, also using the Ecoinvent 3.6 database, which we, by the way, just published the new version 3.7 for this week. So this is available now via openLCA Nexus. And yes, she did some really interesting work on the scooters, on scooter comparisons, and used the openLCA software for it. So I think it's really interesting to see the results, and I'm looking forward to this. So I leave the stage to you now.
Okay, thank you, Pia.
Okay.
So let's start. I'm Thais Barreiros. I'm intern at Green Delta, as Pia mentioned. And today I'm here to present this case study. Like, the name of the case study is the comparison of the life cycle of different scooters used in Berlin. This is a live section, so in the end I will answer all the questions in the chat, so you can type, and then at the end I will see them. And also, if you prefer, you can also mention the number of the slide, because then I will be able to answer them more properly. So let's start. Okay, so the content of this presentation, I will start in mentioning the introduction and motivation, why I'm doing this work, why we decided to compare scooters. Then I will mention how to define the goal and scope and how I did it. Also, I will mention how you can choose the data for the inventory, and then how to perform the impact assessment, evaluate the results, and finally the limitations of the work. Besides that, during all the presentation, I'll try to give some modeling tips. So I hope that it's useful for you. Okay, so let's start with the introduction and motivation. We are all aware that urban mobility nowadays sometimes represents a problem, because we have not always a good public transportation system, and we have different means of transport in big cities, in big city centers. And one important category are the two-wheel vehicles, and we can mention the scooters, the motorcycles, and some other models. But we decided to focus on the scooters because they are attractive, because they have a reduced cost, and also because usually they have a small size, so it's better for mobility. But what's common in literature is that they are reported as one of the main sources of urban pollution. This means that they cause a lot of, we will investigate that, a lot of environmental issues, but also health problems. And when we are talking about scooter, it's important to mention that we have 3 main models. We have the 2-stroke engine that uses a mixture of fuel and lubricant oil. And usually, if you look in literature, they have a high emissions of some pollutants, such as the hydrocarbon, the carbon oxides, and the particulates. And we can find that we had some incremental improvements from the 2-stroke to the 4-stroke model, because we only use the fuel without the lubricant oil, and they have a high emission of nitrogen oxides. This means that the other pollutants, they are emitted in a lower amount, but the nitrogen oxides, they have a higher emission. And finally, we have the electric scooter, and they use electricity. They have few emissions in the use phase, but we also need to consider the electricity that is used. So maybe if you change the electricity mix, the impact will change, and that's what we will evaluate in this work. So the goal of this work is to compare these 3 models, okay, the 2-stroke one, 4-stroke, and electric scooter. And for the motor scooters, we are considering that the scooters have the size is 50 cubic centimeters. And for the 3 scooters, we are considering that they are used in Berlin. We decided that we are going to do this from cradle to grave, okay, which means that we are considering until the end of life. For the motor scooters, we need to collect a lot of data, but preferentially we are collecting data from Euro 2 models and considering direct injection and the use of catalyst. So when you are performing one stuff like that, you always need to be sure which type of data you are collecting. Regarding the scope, the software that we are going to apply is in openLCA. As Pia mentioned in the beginning, we use the Ecoinvent 3.6 database. The impact assessment method that I choose is recipe, midpoint. And the functional unit is 1 person kilometer. Okay, so besides that, we also need to define our system boundaries. So for instance, for the motor scooter, we can consider it first a step of production, and then we need to transport the scooter into Berlin because we are considering that they are used in Berlin. And then we have the step of manual dismantling. And finally, we have one final process that has no really physical meaning, but just to connect these two processes. Maybe this is not the way that you are using to see the system boundaries, they connecting the final process, but I will also show another approach that has the same result in the next slides, okay? And everything that is inside this blue box, it's part of our foreground system, but we also need to consider the background, so the energy, raw materials, and all the emissions. Okay, for the electric scooter, the boundaries are a little bit different because now in the use phase, we need to consider that we have to use the electricity, but we also need the battery and the charger. So all these, all these flows, they are considering the use phase. Okay, and in order to simplify the modeling, we need to make some assumptions. And so, for instance, this table here summarizes the main assumptions because you need to guide the way that you're collecting your data. So, for instance, for the electric scooter, I selected the model from Vespa Elétrica, and then you can find the weight of the model and the place of production that will be relevant when you are implementing data in the software. For the two-stroke scooter, the model that I choose is from this company. I think it's Genuine Scooter Company. And also you have the weight, and you can find or estimate the weight of the place of production. And then for the four-stroke scooter, I considered the model from Yamaha, and this model has 97 kilograms, and according to the data that I collected, it seems that it's produced in Japan. Regarding the duration of the scooters, it's necessary to also try to understand for how long you can use them and what is their occupancy. And then you can see that according to this reference from 2010, the scooters they can last around 50,000 kilometers. Okay, and because they have an extra seat, the average occupation is 1.1 passengers. And so if you multiply these two numbers, you can obtain the duration of the scooter in PKM. So this shows that the data was obtained preferentially from suppliers, so we started from the companies. After that, the data were collected. When it's not possible to find the data from a company, we collected data from literature, from papers. And then finally, when it's not possible to find nothing else, we use the data from Ecoinvent. Okay, and regarding the emissions, we also need to do some important assumptions during the use phase. So for instance, for the two-stroke model, we need to collect different data from different sources from literature. For the four-stroke model, we are not able to find the emissions for this model itself for all the components that we want, all the compounds that we want. So we calculated or we collected from literature the ratios between the two-stroke and four-stroke and used this to calculate. And finally, for the electric scooter, the results, the emissions are from Ecoinvent. And in the end of life, we consider that what is occurring is a manual dismantling. Okay, so let's go to the inventory. So if we start talking about the production, you can see that here is in this slide all the three like all the three production processes were from Ecoinvent 3.6. But it's important to highlight that Ecoinvent has only one process for the production of the motor scooters. So it means that for the two-stroke and four-stroke model, the same production process was considered. And also, I would like to highlight that when we are using process from Ecoinvent, we really need to try to understand them, because we are not the person that build them. So, for instance, if we look in this process here, we can see, for instance, in the outputs that we have the motor scooter, but we also have the used or unused flow, used motor scooter. This means that in this production process of the motor scooter, the used scooter is already considered, like the end of life flow is already considered. But then if you go to the electric scooter production from Ecoinvent as well, we don't see this output of a used electric scooter. So maybe when you look at this, you think, okay, I need to, because you want to compare these different processes. So maybe you think, okay, I need to add the used scooter in the electric one, or I need to remove the used scooter for the motor scooter. But this may not be true. So for instance, if you open the provider of the first flow here, you will see that, okay, we are producing one flow of the scooter, but the used one is already considered. So everything's fine. You don't need to add or remove any flow. You can really use them to compare. I'm just showing you this because depending on the system that you are modeling, maybe you need to take this into consideration and change something in the Ecoinvent process. Okay, so the next step is the transportation of the scooter. And then usually when we are talking about transportation, we need to consider the weight of the scooter, of what we are transporting, and also the distance. So because we have the data of the mass of the scooters from the suppliers, so from Yamaha, from the Bud scooter, it's possible we know the weight, and then we need to understand how the scooter is transported from the production place until Berlin. And this is not always available, but then we need to make some reasonable assumptions. So, for instance, the two-stroke scooter is in China, so it's fair to assume that it's going into Rotterdam by the ship. Then you need to look on the internet, like the distance port from one port to another, and then convert to kilometers. After that, when the scooter is already in Europe, in Rotterdam, they are probably transported by train until Berlin, and then inside Berlin, because they are going into the city center, to the store that we are considering the commercialization, then they are probably going by lorry. So this also needs to be considered. And then the output of the transportation step is one item of scooter transported. Okay, continuing in this part, the next part is the use of the scooters in Berlin. When we are talking about the use of scooters, we know that the motor scooters require fuel and the electric one requires electricity. So we need to collect data about the fuel consumption from literature or from the supplier. So for the two-stroke model, I didn't find the fuel consumption of the specific model that we are considering. So I collected it from literature. And this petrol two-stroke blend is the name of the flow from Ecoinvent that was considered. And for the other model, I was able to find the fuel consumption of the model itself. But it's important to mention that in this step of the use of the scooters, I modeled everything considering the total duration of the scooter. So the total distance of 50,000 kilometers and 1.1%. Okay, regarding the electric scooter, now is a bit more complicated because we need to consider that we have a battery, and the weight of the battery you can take from the supplier. But then we also need to consider the production of the battery, and then you have two possibilities. Or you use the flow from Ecoinvent, and then you already take into consideration the process considered there, or you can model by yourself, like how the battery is produced. And I did both, because I considered the flow from Ecoinvent and also the battery applied in electric bus in Frankfurt Airport according to one reference. And besides the battery, you need to consider also that there is some input of electricity in the use phase. And for that, you need to understand like what is like the electricity consumption of the scooter. So if you have the battery voltage and the capacity, you can calculate the consumption in watts hour in this case. And then also, when you collect information about the battery, you need to understand, okay, the battery lasts for, in this case, for 100 kilometers, 1,000 cycles. So you know how many times you need to charge your scooter, considering the duration that we assume it to be. So you see that you need to charge your scooter 500 times. And also, one more thing that we need to think is like the number of batteries that your scooter will use during the entire life cycle. And okay, we know like that the scooter, we assume that the scooter can last 50,000 kilometers, and we know the duration of the battery. If you calculate, you see that with one scooter, you requires like half battery. So, but this is like unlikely because we consider that the duration of the scooter is like from a reference of 2010, and the battery we are considering the optimal conditions of use. So we decided to assume one battery per scooter. Okay. And finally, besides comparing two different batteries, we decided to compare three different electricity mix. Because if you go in Ecoinvent, you have the German electricity mix there. Okay, that is already modeled. But you can also model this by yourself, which is the Germany, I wrote here normal, like mix. And also you can model by yourself the green electricity mix, and then you can compare it then. Also, in the use of the scooters in Berlin, we need to consider the emissions. So, for instance, for the electric scooter, we have the emissions that we collected from Ecoinvent, like brake wear, road wear. For the two-stroke model, as I mentioned, we collected data from literature. So, for the organic compounds, carbon monoxide and carbon dioxide, we collected from one paper. But then from the metals, I didn't find one reference for like really the emissions of metals of two-stroke scooters, but I found a reference that mentions, for instance, the emissions of metals of other two-stroke devices, so that was considered. We also need to consider that sulfur dioxide is emitted, and then for this, one alternative is to calculate according to the sulfur content in the fuel. And finally, for the particulates, I calculated them considering a combination of data from Ecoinvent and literature. For the four-stroke model, as I mentioned, I didn't have access to like the emissions of the four-stroke itself. So I tried to find, for instance, that 95% of the hydrocarbons are reduced in relation to the two-stroke. So I used these factors because I already knew the number for the two-stroke to calculate the emissions of the first stroke. Okay, the last part of the use phase is that we also need to consider the road, the scooter maintenance. And for this, I used the data from Ecoinvent. But again, when you are comparing two different processes, you need to make sure that you are doing a fair comparison. So I think one of these flows, I think it was the road, it was only for one scooter available, so I included for the other as well. Okay, and everything in the use phase was calculated considering one used scooter and this duration that you can see in this slide. Finally, we have the dismantling. And if the dismantling for the three scooters was considered the same and was based on Ecoinvent process. And here you can see, for instance, that the input is just the manual treatment facility. And then as output, you have the e-scooter end of life. There is just one flow to connect to the next one. And they use the lithium-ion battery. Maybe you're wondering, okay, why I don't have a used scooter here? But because this flow was already in the production slide as I showed. And finally, our last part is that we have this final process that connects the use and the manual dismantling. And here, as you can see, we are only considered as input in the final process 1 ppm, okay? And because, as I mentioned in the beginning, this is our functional unit. But if you prefer to model in a different way, it's also possible. So for instance, if you use the material flow logic, you would consider that okay, the manual dismantling actually after the use in Berlin, and not, you don't have that final process connecting. And that here I put a picture of how you would do this on openLCA, and the results are the same. So you can do like the way that you prefer, but usually we're doing the other way just to highlight our reference process. Okay, so after you implement all of these in the software, you are able to obtain like model graphs, and the model graphs, they are interesting because they show the complete supply chain and how the process and flows are connected. So here you can really see that like what I considered, for instance, for the two-stroke scooter, that we have a final process and then the use process and manual dismantling connecting to this process. Here is just our second product system, that is for the four-stroke scooter. And finally, for the electric scooter, our third product system. And maybe you are wondering why this model graph is more complex than the others. And it's because, as I mentioned in the beginning, we are comparing three different electricity mix, and we are also comparing two batteries, and then they are all connected in the use phase, so that's why it has a lot of inputs. And that's why I said in the beginning that I would give some modeling tips, because with the use of only one product system, in this case of the electric scooter, we will be able to evaluate 6 different scenarios through the use of parameters. So, for instance, as you can see in this slide, we are considering one scenario for the two-stroke scooter. That's the first model graph that I showed you. The second scenario is for the four-stroke scooter, and then more 6 for the electric scooter. I will show how to do this in some minutes in openLCA. But then here you can see, okay, the scenario 3, which is the electric scooter 1, we have the battery from Ecoinvent and the electricity mix from Ecoinvent. And in the others, I change the battery or the electricity mix. And how you can do this? Okay, we have here in this picture, you can see, for instance, that the battery, we have like 2 batteries, and then one is multiplied by B1, like the weight of the battery, and the other by B2. And what is the meaning of that? Is because, for instance, if you go in the parameter section, you see that I put in this example B1 1 and B2 0. This means that I'm not considering the second battery, which is the battery that I model. So if you only change the numbers in the openLCA software, you would be able to really, change the scenario that you are considering, only change these numbers. And this is really helpful when you are in the calculation phase, but I will show this soon. Okay, so when we are talking about the impact assessment, so you can calculate the results using the software, and then, for instance, for the two-stroke scooter, you see that most of the impact categories, the main impact is in the use phase. And but there are some important exceptions. So, for instance, for mineral resources scarcity, we can see that the production is it's the hotspot in this case. And this is because we are considering a production of a scooter, which means that you need to consider zinc production, steel production, and then that's why here the hotspot is the production. But in the others, the hotspot is in the use phase, for 2 main reasons. One is the fuel applied, and the other one are the emissions that are generated. So, for instance, if we go for fossil resources scarcity and we try to understand in the software, the main reason for that is the fuel applied that I showed in the beginning, the blend that is used. And if you look in global warming, so for global warming, we can see that if you see the distribution of the impact, the main focus is in Europe. So the main focus is really more or less where the scooter is used and is related to the emissions, mainly the emission of carbon dioxide. And this is interesting because in one of the first slides I showed you that the carbon dioxide emissions is one of the problems of the two-stroke scooter. Okay, if you go for the four-stroke scooter, the use phase again is the problem of most of the impact categories, and the result for the mineral resource scarcity again is the same. In this step, we are not yet comparing the different scooters, but just showing how we can look at the results and try to understand them. Finally, for the electric scooter, you can see that again the use phase is most of the impact categories, the biggest impact is in the use phase. But now we need to consider that this use phase is not because of the fuel anymore. We have the electricity, but we also have the battery, we have the charger, everything is connecting in this use phase. But I won't show you the results of the 8 scenarios because now I will show you how you can use the parameters to really compare them in an easier way. So, just 1 second. So this is the software, openLCA. And then, as I told you, I just have 3 scenarios. I just have 3 product systems, sorry. So just consider 2S2, 4S2, and electric scooter here, okay? And then, through the use of parameters, you can really create a project. So here I will call comparison. Okay. Yes, so here you can come here in this part, compared product system, and then you will add the product system that you want to compare. So you will add 1 time the 2-stroke scooter and 1 time the 4-stroke scooter because you just have 1 scenario for each of them. But then for the electric scooter, you want to evaluate 6 different scenarios. So you need to add these 6 times. Just a moment. And then just to be easier for you, just change the names here. Sorry. Oops. And then you can change the name for all of them. And then after that, you need to select here which parameters you defined that you want to change when you are comparing the scenarios. So what you need to think, the part where the parameters and they were changing something is in the use phase of the scooter. So you need to come of the electric scooter, sorry. So you need to come here in your process that you create. In my case, use of the electric scooter in Berlin. And then you need to select the parameters that you want to change. In my case, they are B1 and B2, because then I can change the battery that I'm choosing, and D1, D2, and D3, because then I can choose the electricity that I'm considering. Then you add everything here, okay? And then now you just need to add the number that you were considering for each scenario. So for the 2-stroke scooter, 4-stroke scooter, none of them use battery or electricity. So you just put 0 for everything. And then for the other models, like the electric scooter, you need to modify the numbers. So for instance, this scenario here, consider the battery and the electricity from Ecoinvent. So it's 1, 0, 1, 0, 0. But this one here is the battery it's also the battery from Ecoinvent, but it's the green electricity mix. So we put here 1 and 0. Because this means that if B1 is 1 and D1 is 1 and all the rest is 0, so you are putting an off in these other parameters, so you are not considering the other electricities, and you are just considering 1 battery and 1 electricity mix. And then after you change all of them, you come here and you select your impact assessment method. In my case is this one. And then you just click in report, save it, and click in report, and then you calculate. And this is important because this gives you the opportunity of, okay, so this gives you opportunity of, instead of doing 8 different calculations, you will be doing like tables summarizing all the results for all the scenarios. And also is important, so you can already see just doing these like this project and creating the report that you really, okay, so for the two-stroke model, like these are the impacts, and then you can compare all of them, and then you can also obtain like graphs, like comparing, in my case, the 8 scenarios. And now I will talk about like what is the advantage of each scooter and really compare the scenarios. But I think that is quite hard to compare 8 scenarios at the same time, like to understand what's going on. So I divided them just to be easier to compare. And this will be our interpretation. So if you just consider, okay, I want just to compare the two-stroke scooter, the four-stroke scooter, and the electric one, but from like everything from Ecoinvent. Then you with that table of like the results of the impact, you can, for instance, plot just the one that you want, or just create a product considering a project considering 3 scenarios, and then you will obtain like this type of graph. And here, like the impacts that, for instance, the scooter that has the highest impact will be with 100%, and the others will be always in relation to that. So this is quite useful for us because we can see that, for instance, for global warming, the two-stroke scooter has the highest impact. And then we have, I mentioned in the beginning, okay, for the two-stroke scooter, for the four-stroke scooter, we had an incremental improvement, and you can really see this in global warming because then the impact is reducing and reducing even more when you're considering electric scooter. The same is true for fossil resource scarcity. And this is because of the emissions and the fuel that change. But this is not true for all the impact categories. So, for instance, for fine particulate matter formation, the four-stroke scooter has the highest impact, but I showed you in the beginning that they have a lower emission of particulates. And why is that? Because the four-stroke scooter has a disadvantage, that is the emission of nitrogen oxide. And because of that, this flow is extremely important when we are considering this impact category, or for instance, terrestrial acidification. And so that's one way to compare the scooters. But then if you think in global warming, you see that the electric scooter has one of the lowest impact. And in this case, we are considering the mix from Ecoinvent, like the traditional mix from Germany. And then if you like compare only the scenarios that change the electricity mix, all of them for the electric scooter, and if you think again about global warming, for instance, the ES2 is the one that uses the green electricity mix. So it has the lowest impact. So depending on the electricity mix that you use, you are really able to reduce your impact. And this is really like advantage. Then this shows that we can, like, with the electric scooter, we can solve some issues of the two-stroke and four-stroke scooter. But if we change out the electricity mix, the impacts are even better. However, it's hard to say that one scooter is better than the other, because this is not possible. Like, depending on the category and depending on what you are looking for, then your conclusion changes. And it's also important to show you that even when we consider the green electricity mix, the emissions is still focused on like Europe, now a little bit also in Asia. But in general, like the emissions is still focused on the city centers and Europe. And finally, because I also said that we would compare like different batteries, and this is just to show you that if you change something, like, okay, I won't consider Ecoinvent, I will consider something else, the results will also change. So in this case, I'm comparing like the first scenario, the blue one, is the scenario that I use the battery from Ecoinvent, and the other scenario is the scenario that the only thing that changes the battery is the battery modeled by me. So you can see that, okay, for some categories the results are really different, but for water consumptions, for instance, it doesn't make that difference. And this is important just from educational point of view. But however, I cannot say like one battery is better than other, because in this case, the blue one, like blue scenario, is considering a battery that can be applied for any electric vehicles, while the other one is for electric bus. So none of them are specific for a scooter. And so this is just to show you like the conclusions and the results. And finally, we have some important limitations in this work that should be mentioned. And so, for instance, in the beginning, I showed you that I considered the same process of the production of the two-stroke scooter and the four-stroke scooter. But obviously, if you go really in the producer, this is not true. Like they are produced in different ways. Something should be changed. Besides that, the emissions are not from the specific model. Okay, they are, for instance, for the two-stroke scooter, they are calculated from literature, and for the four-stroke scooter, they are calculated according to the two-stroke model. So if we obtain more specific data, then this would be better. And finally, we didn't consider that, for instance, probably a new scooter will has the consumption and the emissions will be lower, and if you compare with one scooter that you already have for years. So this is not considered in this study. And the last thing that I should mention is that I explained that we consider one battery per scooter. But if we figure out, for instance, that the battery lasts more than the scooter, and then we should define another use for the battery, which means that it can be applied for something else, then the impacts will decrease. However, if we understand, okay, we need actually more than one battery during the lifetime of the scooter, then you need more batteries, and then the impacts will increase. So these are the limitations. And so now I will answer the questions. Thank you for your attention, and please feel free to add more questions if you have.
I will come here. I can now check the questions here. So first of all, thanks a lot for the presentation, Thais. Thanks also for everyone who was commenting. We are aware that you need a Google account for it. Still, I hope that there are no questions from someone who was not able to write in the chat now. But maybe to mention these questions, there was one at the very beginning from VA who actually asked why you used 1 person kilometer as a functional unit when the 3 scooters have the same occupancy rate. He says it's a question, is it really relevant to the scope of a comparative study? So
yeah, if you want, you can also choose your functional unit as 1.1, like pecans, but then you need just to select the same functional unit for all the 3 scooters, so you are aware, you know that you are comparing like the same thing.
Exactly. So I think it's less about the difference, right? So it's just important to define it at some stage. And she chose now 1 person kilometer. You can have also chosen another reference flow, which is which you would scale up or scale down. But yeah, as you also mentioned, in the end, it doesn't make a difference. But of course, you still need to define it in order to refer your results to a certain amount, to a certain number exactly. Okay, but thanks for the question. Also, if you want to refer to our answers, just comment again. Then there has also been a question from Kasia. Could you please go over again about how you did enter the emission outputs and how did you select them?
Yes, so maybe it's easier if I show you the software. So I will show, for instance, the emissions for the two-stroke scooter. Okay, just a moment. So if you come here, okay, use of the two-stroke scooter. What I did is, for instance, for this one, I selected in literature, like I tried to understand, okay, what is emitted? So for instance, here, like organic compounds and also metals. And then I really tried to collect, like, okay, how many milligrams or kilograms per kilometer they are emitting. And then this was for the two-stroke scooter. Then I really collected this and just corrected according to my to the reference flow of these phase. But then if you go to the four-stroke scooter, what I said is that I didn't found the exactly emissions of the four-stroke scooter. So if we open here the use of the four-stroke scooter, you can see, okay, so for instance, if you compare here one butene with the one of the two-stroke scooter, okay, the formula is the same, but then here, look, 4.7, but then here I add a factor in the end, because I look at the literature, okay, what is the difference of the emission of the two-stroke scooter and four-stroke scooter? So I used the same formulas, but just added here the factors that I found in literature or that I calculated, for instance. And it was something else. Now for this question, could you please go over again? So that's how I did. And for the electric scooter, just to complete my answer, for the electric scooter, I just consider the emissions that are already in the Ecoinvent process. So for this one is the easiest one, I guess.
Okay. So Kasia, we hope that this answers your question as well. We have one more question from Ankit, and if not, please also write another message in the chat. Ankit was first saying thank you for a very interesting presentation. Shout out to you, Thijs. And he was asking, during the use of scooters, if we incorporate repairing, would it have impacts on your results?
So I must admit I didn't check it like exactly the impact of the repairing, but at the end what I did is, for instance, because you can look in your contribution tree, you can look in your impact results, and then like the repairing tool didn't appear in the impact categories that I looked at as one important contribution. So I think that my answer is no.
Okay. So, well, that means basically you modeled it and you also included it once.
I included.
Right. When you really saw from a more or less, you could say it's part of a sensitivity analysis, maybe at the beginning of your study already, where you more or less try to estimate how high would the impact be, and how, if it's very, very low, it's maybe also not worth the effort to look for more data here.
And just to show here is the flow I considered. Yeah, but then, that's what we explained.
Okay, thanks a lot. And thanks for the question, Ankit. But yeah, or maybe to add here, of course, whenever repairing is part of maintenance more or less, and whenever, for example, let's say energy is included in the maintenance, then of course it would also increase your impacts over the life cycle. And then it again depends on the scope of your study, basically if you include maintenance or if you don't. Yeah. Thank you very much. So Gabriela was also asking a question. Her question was about the differences between the two batteries. How can you say that there is a quantitative difference when there is more than 20% difference? Or that was the question. When there is more than 20%, did you use an analysis like Monte Carlo?
No, I didn't use analysis like Monte Carlo, but you can use. But because like in my case, I just really wanted to see if the results would change a lot. But yes, I understand your point. Like, what means this? Like a really big difference. So, but no, I didn't use Monte Carlo.
But yeah, in general, you're right, Gabriela. So it's definitely possible to to also use Monte Carlo analysis in openLCA. So you could definitely apply it, of course. Very good. Another question from Bruce Lee. Can you use the database in openLCA as a basic database and use it in CREAT?
What is CREAT?
Yeah, okay. So I guess you mean the US American model for calculating greenhouse gas emissions from transportation. Is that true, Bruce? If yes, you were asking if you can use the database in openLCA as a basic database and use it in CREAT. So I'm not sure if I fully understand. So basically, CREAT, you can say, is also a database and also a model for calculating the carbon intensity of transports. So it would mean, here Thais was working with Ecoinvent 3.6, and yes, you can use it in openLCA. So if you have a license or any kind of license, you can import it to the software as a basic database for your background data, as Thais now also used it, and then you can model your foreground system here. But I right now don't understand what should be the connection then to CREAT. Of course, you could either use the results for using them in CREAT also. Of course, you can also use the background database and use some of the results from the background database or also from the inventory to combine it with CREAT. That would also be an option. But yeah, maybe you can get more precise if I have not answered your question already. Okay, VA was asking something else. He's also interested in knowing if it's possible performing a Monte Carlo in openLCA focusing only on the set of parameters disregarding the pedigree matrix.
But then in this case, I just used the parameters. The other parameters, because the parameters is like the battery and the scooter is I just like 1 or 0. But then for the others, I don't know.
Well, yeah. So basically, of course, with different parameters, you can basically create different product systems, and it's possible to create to compare different product systems or processes using different parameters. So so it's not only possible with the pedigree matrix, so that you define the uncertainty of your data. So it's also possible with the results to compare them using different types of parameters. Yes. Okay, Bruce Lee. Okay, it seems like we have answered your questions or your question on greed. That's good. Also, Gabriela, yours. That's also good. Okay, we wait for maybe 1 more minute or 2 more minutes. Maybe in the meantime, I can say that we want to push on this format with the live streams. The next live stream will be beginning of November probably. So we will then introduce the Ecoinvent 3.7 database, the next one after, or the updated version of the one that Thais was using. Yes, and it will be presented by our CEO Andreas Sirot and our data analyst Salma Burhan. So I think it's going to be really interesting, and it's really going to show all the updates that we have in the Ecoinvent 3.7 database. We keep you tuned for the exact date and time. via our various channels. So we have the LinkedIn channel, we have here the YouTube channel, and we also have our Twitter channel. Oh, we just see another question from Angel. Maybe you missed it, but could you please show the electricity mixes that you have used? What is the share of coal in the German electricity grid? Good question. So I think Thais can deliver this.
Just 1 second. How's the height here? No, on height. It's in German.
Height ausblenden. Okay. Here. Just click it.
Yeah, so like to answer your question, one of the electricity mix considered was from Ecoinvent, so I didn't change anything. But for the green electricity mix, this was the shares considered, okay? And so no coal here. And here for the electricity mix, like the complete one, here is the distribution that was considered according to the reference. So like I think these answer your questions, like hard coal power plants and also coal gas use. So that's it. Like this is the what it was considered.
Okay. Very good. So how do you explain that the impact on GDP is lower in electric scooter than for a scooter? Maybe efficiency of electric scooters? Do you have a technical explanation for that?
No, I'm thinking that maybe like because of first, let me just check here and it's lower in the, because we also need to consider the emissions, like we are considering less emissions for the electric scooter. Maybe this like the only thing that I'm able to think about, and yeah, also the efficiency. Not sure.
Okay. Yeah. So we don't 100% know, so we didn't trace it back further. Yeah, so it could have various reasons, among them efficiency. And Bruce added a comment to his question. So the grid is a software used in calculating the transportation emissions, exactly. You said you used the openLCA database as the LCA of my model. So yes, so openLCA itself is never, or is not a database. So openLCA is a software and which is available open source, and you can import various types of databases such as Ecoinvent into the software. So some of them are free, for some of them you need to purchase a license. Probably you have used any type of database in openLCA, and these datasets you might have used. But yeah, you can also calculate greenhouse gas emissions from transport with using the GREET software, especially in the US American or Northern American context. And then you can of course always use that data from your GREET calculations for importing or for using them to model your foreground system in openLCA. So that would mean that you would basically combine various data sets in openLCA. So I hope that will help you. But yeah, it's definitely possible to do that. Yeah, but keep attention that openLCA is the software environment and not the database itself. Thanks, a lot of questions. That's really nice. Yeah, we are happy. That it contributed maybe also to your understanding for modeling in the field of scooters. And maybe that it also showed you what's all part or what can be part of an LCA study in this field. I mean, you have also seen that Thais also included aspects like road maintenance, etc. So it can become really comprehensive depending on how you set your system boundary of your system. And I think that's really interesting what we have seen here. And of course, in case you have any questions about the model, I mean, we have also a report for it, which Thais has prepared. And if you have any more specific questions, then you can definitely also write below this video. We are going to publish it on YouTube, and then you can comment on it, and then we have the chance also to answer your questions in case there will be more. Very good. So thanks a lot. There is now another question. Balai, you were asking something. How do you justify the investment of environmental impact reduction project with LCA parameters? So I think you're referring here not to parameters that we're using as part of an LCA study, but more how would you use an LCA for justifying an investment in your company, probably, right? Yeah, that's a good question. I don't know. Do you want to use this?
Yeah, maybe because, for instance, with this impact assessment method that we use it, you can see, for instance, like reduction in water consumption, and then you can use these in the investments, but or you can also say, okay, I can see that if I compare my you're comparing technologies, right? No, in the project. Okay, so if I compare my company in the way that the company is now with the impact, like the global warming impacts after it, then you can also use these to reduce, like to justify your investment. And also because I'm probably depending on where you are, maybe the companies can receive some like how can I say, subsidies from the government if you like comply with some, I don't know, some emission standards. So.
Right, I think there are many reasons for it, and it depends very much on the company. It's very individual. So, of course, I mean, LCA, first of all, definitely helps you to prevent any burn shifting within the life cycle. So your company is maybe one stage in the life cycle, and if you calculate not only the environmental impacts which happen at your place, but really over the whole life cycle, you make sure that you maybe by using a certain type of material instead of another, that not only your environmental performance becomes better, but really also the complete life cycle's performance becomes better. I think that's a huge aspect, and then it really depends more on your company if the motivation is maybe more intrinsic, or if it's so that you really want to improve as a company from a sustainability perspective. But yeah, if you say you need to justify it, then I think there are many reasons which are related more to marketing and to the development of your company. I mean, of course, there are also aspects such as risk assessment. I mean, if you see somewhere in your supply chain or in your life cycle there is a huge water issue and there's a high water scarcity, but the process is that you are very much depending on water, let's say. I mean, it's a simple example now, but then of course this could also become a risk for your company. But yeah, I mean, what we see most is that really more and more companies are also asking their suppliers to deliver mainly the global warming potential numbers of their products, but more and more also other environmental impacts. And of course that end customers are asking for it. And that companies need to become more sustainable in a way, and LCA is a tool to quantify it on a product-centric basis. So not for the whole company maybe, there is also an organizational LCA method, but what Thais has now done is really a product-centric LCA, and it might be a tool to quantify the the environmental improvement of your investment also. Yes. So, and yeah, as Thais said already, resource efficiency is of course a huge part, which you can also then show in the via the LCA. You can show how much this contributed really. Yes, so I hope your answer or your question has been answered. It was maybe not relating directly to the case study of Thais, but was more generic, which is totally fine. But yeah, I think we will now finish this live stream. As I said, expect us in beginning of November again with the Ecoinvent 3.7 live stream. Thais, thank you so much for taking the time and also preparing this. It's very nice. And as we said already, just write into the comment section if you have any more questions.
Yeah. Thank you, guys. So this was my first webinar. I hope that was good. And thank you for your attention.
Okay. Goodbye.
Bye.